This is the 11th. So here it is, guys. This is our first review, our official review. It is on particle motion. Sometimes it's called position, velocity, acceleration problems. This is guaranteed to be on your exam. It's guaranteed to be a free response question for sure, 100%. You'll probably see it also in multiple choice. I was looking over the last 10 years and I put these questions together. There's 5 of them total. I put the hardest 2 as the first 2 problems, and you're going to notice something very similar of why they're the hardest, quote unquote. And then I put some of the middle tiers, and then I gave you guys something that I think you guys can achieve and hopefully beat the average, the mean score. Don't worry, we'll be fine. We're going to go slow. We're going to first start with just what we know about position, velocity, acceleration. Okay, so what's the derivative of what? So usually if it's particle motion, if it's motion in the x direction, usually they call that x of t. And I'm going to say that's like position on x-axis. If you are going up and down, then instead of x of t, what do you think they call it? Y of t. And sometimes they don't tell you that you're on an axis, period. They just tell you, here's my position equation. And sometimes they'll call it S of t. And there's other equations. Maybe they call it p if it's particle p or whatnot. And then how do I get velocity from position? The derivative. So usually you want to notate them, like you want to connect them. You say this, v of t is equal to x prime of t. Yes, you can also say dx dt if you want. Or v of t is equal to y prime, or whatever the position equation is, you want to take the derivative of that. And then how do I get acceleration? The derivative of velocity, and you want to make that connection there. You can also say the second derivative of position. What else do we know? Let's see. From physics, how do I find average velocity? Do you guys remember? Just from physics, no calculus. No, not speed. Speed over time, that would be like acceleration. Displacement. So write displacement divided by time. That's just from physics. In calculus, how do we say displacement?
Change in x.
Oh, okay. You can say that's like physics, right? So she's saying change in x or change in time. So I'm going to write x of b minus x of a for displacement. That's still from physics, right? X of b minus x of a, where a is some initial time, b is some time after a. Okay, now how do we say displacement in calculus with an integral symbol? No, not absolute value. V of t. Area under the velocity curve. If you have some velocity that's positive and you have some velocity that's negative, I'll just, bless you square. I'll just draw something random. If I tell you that this is 2 and I tell you that this is 5, and I'm going to call this V of t, and I guess I'll say this is 0, this is A, and this is B. Notice that I'm starting at 0. If I go integral from 0 to B of V of t dt for this one, you're going to tell me what? -3. Because I have a 2 above and I have a 5 below. So that just means that my displacement is 3, that I move 3 times to the left with respect to where I started at 0, at time t equals 0. Does that make sense? Okay. So let's make a connection here, guys, real quick with these two. I'm going to write it like this. So do you agree that I can say x of b minus x of a is equal to integral from a to b, bless you, of v of t dt? And don't get this confused with this picture here. I don't want you guys to start thinking. Let me go ahead and put that outside of that. So that is not indicative of this a and that b. Do you guys agree with this statement here? Yeah. X of b minus x of a, that's displacement. This is displacement. So what if I told you I want to find my position at some time b? So I can just move this x of a to the right and look what I have. And this is where I want you guys to become automatic with this. You don't have to be automatic, but it would definitely save some time if every time you get a position problem and says, what's my position at time t equals 3, that you just default to this. The position given plus the displacement will give me my position at B, at time t equals B. Does that make sense?
No, can you say one more time?
Yes. Do you agree, Houston, that the integral from A to B is just displacement?
Yes.
So what if they told you, I want to know my position at time t equals B? Notice that I can, if I move that to the right, I can just say my position given to me at A plus the displacement will tell me my new position. And it makes sense from physics.
Yeah.
You got a position, you tell me how much I moved, and now you can tell me where I'm at now. Cool or not cool? All right. Look at this, guys. How do I find distance? Absolute value from A to B, absolute value of velocity. See, you guys already know a lot. Let's see, what else?
Are you telling us this because it's like a lot of like IQ questions?
Yeah, this is just a dump of what we know. Look, referencing this, because this comes out all the time. What's up?
What's the importance of the absolute value?
Good. Thank you for asking. See, I need you guys to ask. When you put the absolute value, see how it says absolute value of V of t? That will turn this like this. Anything that's below the x-axis will get reflected. And now, look, so if I do this same thing again, 0 to b, absolute value of V of t dt, look what it'll give me. 7. So if they tell you what's the distance traveled between 0 and b, you're going to say, well, I traveled 7 units, whatever that may be, because that's how much you did. You did 2 units to the right, and then you went 5 units to the left. You traveled a total of 7 units. But if they tell you what's the displacement, -3. Those come out all the time. Good job. Ask me more, guys. Ask me more. I wanted to look at this real quick. Remember, and because this is important, guys. So if I told you what's average velocity, and you're not doing it like this, but you're doing it with calculus, a lot of times you'll see it like this, guys. 1 over b minus a, integral a to b of v of t dt. Relax. That's the same thing. You could have said integral a to b of v of t dt all divided by b minus a.
What do you balance it?
This is the average value, average velocity.
But b minus a gives us the time?
Yes. See how the change in time. See, this is the way they write it in most textbooks. I haven't seen it written this way much. I have seen it, but not. This is what I see all the time. Not with reference to velocity. They're gonna ask you like average f, and that's how we originally derived it. Remember, guys? Like, how do we find average f? Well, average of f, if average velocity is this integral 1 minus b minus a to b of v of t, then average f is 1 over b minus a integral a to b of f of x. That's just something for us to just make a note of. Are we still okay? Okay, I think we're ready. I'm excited. I hope you guys are excited. Don't worry, we're going to do the first 2 together. And then we'll have one of you guys, maybe we'll call a lifeline for question 3 or okay, let's go to the first question. You're going to eventually need a calculator, not for these. Full disclosure, I did look at the rubric when I was putting this together. You'll see in a little bit. I'm not warmed up. I have not looked at the question and I have not read it. I have not gone over it. So if I make a mistake, I make a mistake. Cool or cool? Cool or not cool? All right, here we go. This question in 2014 only got an average of 2.64 points. So that means it must have been considered, quote unquote, hard. How many points are in every FRQ? 9 points. Try to get at least 4. If you can get more than 4, I would say you're in good company. Are we still okay? All right, so obviously we know there's going to be a position, velocity, acceleration. Let's see what it says. We have no calculator. So I got a table in minutes, 0, 2, 5, 8, 12, and I got V subscript of A, meters per minute, okay. Ms. Kyle, do you want to read this, please?
Train A runs back and forth on the east-west section of a railroad track. Train A's velocity measured in meters per minute is given by a differential function V of A of t, where time t is measured in minutes. Selected values for V of A of t are given in the table below.
Okay. Love it, love it. I'm just going east or west, one direction, and it's just a horizontal movement. So I put an arrow west and east. All right, letter A. You want to read it for us, Ms. Rodriguez?
Find the average acceleration of train A over the interval 2 to 8.
Yeah, you can just say where t is between 2 and 8. That's fine. How do I find average of anything? We just talked about it. No, that was average velocity. So average A equals, you could also do this with physics, I guess, 1 over 8 minus 2 integral from 2 to 8 of A of t dt. That's average of anything. Chav, I don't like to do it this way. I like the physics route. Guys, in physics, the definition of acceleration is the change in velocity, not displacement, the change in velocity divided by time. Notice this right here will tell me the change in velocity between 2 and 8. Chav, I don't see how that is. Guys, it's the area under the acceleration curve. Meters per second times second is meters per second. So it's a change in area, it's a change in velocity. If you don't see it like that, relax. Look, there's so many ways to connect it. What's antiderivative of acceleration? Velocity. So this right here that I'm circling, all this will tell you is just v of 8 minus v of 2, upper minus lower. And check it out, v of 8 minus v of 2, that is the change in velocity. What's up, Henderson?
We have to put variable as A.
Well, yeah, because they want average A. So if they want average A, that's what's going to go in there. If they want average F, then I would have put an F in there. If they want average V, then I put a V in there. So that's using our definition, right, of average. And you don't have to use it. You could have just gone like, whoa, acceleration is just the change of velocity divided by time. You would have gotten the same thing anyways. Check it out, guys. So now look, all I'm going to do, 1 over 6 v times, parenthesis, v of 8 minus v of 2. And I guess maybe I would not have written it this way. I probably would have written it immediately like this. V of 8 minus v of 2 over 6. What's up?
What would it have looked like if they had asked for average velocity?
I would have had a velocity in there and it would have been displacement divided by time. But I don't have access to displacement. I don't have an equation for velocity. I just have a table and they don't give me any x's, like they don't give me any points at the moment. Are we still okay, guys? Okay, this is still not full credit. What is v of 8? Well, I guess I got to put a subscript there. I think you'd be fine if you didn't put that subscript, but we probably should. What's v subscript a of 8? Negative 120 minus what's velocity at 2? 100 divided by 6. So let's see if we can do this. So negative 120 minus 100. Remember, we have no calculator. Negative 220 divided by 6. Okay. If it has units, put units. The top is meters per minute, and the bottom is meters per minute per minute. You can if you want. If you keep making arithmetic errors, can you leave it like that, and will it be correct? Yes, you can leave it like that. Now, anyways, are we courageous at the moment? Can we reduce this? Yeah, what is this? 2 goes into both of these. I don't think 3 goes into both of them. Nope, but 2 does. 2 goes into 22 11 times, so negative 110. And 2 goes into 6 3 times, and then meters per minute per minute. Do you guys want to write meters per minute squared? Okay, there it is. You don't have to. You can leave it as meters per minute per minute. Are we okay with this? Okay, I don't know how many points that is. I remember putting the rubric together or cutting and pasting it. I don't remember the point distribution. All right. Ms. Henderson, do you want to read letter B for us?
Here's the data in the table. The data in the table support the conclusion that Training's velocity is negative 100 meters per minute at some time t with in between 5 and 8 give a reason for your answer.
Okay. Is it just me or do the data sounds like weird? I'm sure maybe in a certain region, maybe in New York or somewhere, it's yeah. I just cut and pasted directly from that year, so I don't know who the author is. All right. Yeah, it's fine. It's fine. All right. So let's talk about this. The train velocity. Before I even start, I can already tell where they want me to go. Is velocity differentiable? Because velocity is differentiable, that means velocity is continuous. Because I'm continuous, what theorem do you feel they're trying to make me use? Intermediate value theorem. So I'm going to write first v of t is differentiable, comma, therefore continuous. You could say in our domain, but I'm going to say continuous on 5 to 8. You don't have to put the equal sign. You can if you want to.
Wait, how is it all the way if it's only asking between 5 and
Say it again.
How's it between all domains if it's only between 5?
Velocity is continuous for 0 on this entire domain because it's a train and it's traveling. Do you know what I mean? So I don't think if I were a reader, which I have been, I don't think I would give them too much of a fuss as long as they tell me that the velocity is differential, therefore it's continuous. Usually you have to state that. You're not always, but I would be more safe than sorry. And then I would say this. I would go immediately and I would go V of 5. And you don't have to even, okay, I'm getting ahead of myself. V of 5. What's V of 5? 40. And then I would go V of 8. And what's V of 8? Okay. You don't even have to mention the intermediate value theorem. I would just state this. I would go, since V of t is continuous on interval, comma, and since V of 5 equals 40, and then tell me if it's right English, V of 8 equals negative 120, comma, there must, and I would double underline the word must, exist a time t where t, and in parentheses I'm right, where t is, I guess, you know what, you don't have to say it like that. I was going to say where t is between t equals 5 and 8. I'm just going to go where t is between 5 and 8 like this, close parentheses. Let's see, there must exist a time t where v of t equals negative 100. And let's read it to see if it makes sense. Since v of t is continuous on the interval and since v of 5 is 40 and v of 8 is negative 120, there must exist a time t where t is between 5 and 8, where v of t is negative 100. Does that make sense to you? Because it's continuous. It must cross y equals negative 100 or v equals negative 100.
And we know it's continuous because velocity is differential.
Correct. You don't have to, but you can. You can say what theorem? You don't have to though, but it would be nice. By intermediate value theorem. Remember, for it to be differentiable, you have to have a nice clean curve with no tangent, with no critical points, with no corners, cusps, or like jumps. Velocity must be differentiable because this is a train. A train's not going to go from 100 miles per hour or meters per minute to 75 meters per minute in a moment's notice.
So we use logic?
So, well, I think it's always going to be, if it's a train, your velocity is always going to be differentiable. I mean, pretty much anything, almost everything that's dealing with motion, unless there's like a instantaneous, immediate jerk, like you're going from 30 miles per second, 30 meters per second to 10 meters per second at a moment's notice. That's not going to happen. It's not going to be abrupt. Not a train. You have to be differentiable. You got to have a nice clean curve. No, that's different. If you have a hole, you're not differentiable at that location. You got to be continuous. You can have a hole and have a limit as you approach, but you can't be differentiable at that hole. And you can't have, like, here's what I'm talking to say, guys. You can't have like a cusp. You can't have a cusp. So at that moment, a cusp is like a corner. So you're not going to have that with the train of a velocity, with the velocity of a train. English is not my best language. Did all that make sense or no? Yeah. Okay. All right. Letter C, we continue. And I can see why this is tough. Let's see. Okay. Don't worry, guys. We'll be done real quick, and we'll let you guys tackle it. It's more fun when you guys are doing problems, I know. Okay. At time t equals 2, actually, Miss Houston, do you want to read this? My voice is kind of...
At time t equals 2, train A's position is 300 meters east of the origin station, and the train is moving please. Write an expression involving an integral that gets the position of train A in meters from the origin station at time t equals 12. Use the trapezoidal sum with 3 sub-intervals indicated by the table to approximate the position of the train at time t.
Okay, first of all, whoever wrote this question is being super cute. I love it. They call the station origin station, guys. I think that is super cute. I like it. Okay, let's draw a little diagram here. I'm just gonna do my little east, west, east, right smack in the middle. I'm gonna call that origin station. And at t equals 2, I'm 300 meters to the. So I'm gonna write point, and I'm gonna say t equals 2, and that gap here is 300. Are we still okay? All right. Okay, here's what I was talking about. That I want this to become automatic for you guys. Write an expression involving an integral that gives the position of train A position in meters from the origin station at time t equals 12. Well, look, here's what we're talking about. Here it is right here. This one. It's going to look like that all the time, forever and ever and ever. We've done enough that I think we can just go right into this. So I want it to look like that. They want me to position right at 12, so I'm going to write. Let's see, what am I going to write? This is position left or right, so I'm going to write x of 12 equals, and they gave me the position at what time value? So I'm going to write x of 2. You don't have to. You can write 300 right off the bat. Plus, and then I'm going to write a what? Integral from what limit to what limit? 2 to 12, and what do I put on the inside? V of t. There it is, dt. There is my expression. I got the point for that for sure. For sure I got that in the bag. What was x of 2? 300. Let's see how hard this is, and we'll see if we determine whether we're going to figure it out or not. Bracket, what's up? It says right here, train A's position is 300 meters.
Then why, so we just don't use the table anymore?
The 100 is the velocity. Now notice what they want us to do. A trapezoidal sum. So from 2 to 12. So check it out. Here are my 3 trapezoids. Say it again. Base 1 plus base 2 times height divided by 2. Okay. Guys, does everyone know what we're doing? You can say no. All I'm doing is finding the area of all these trapezoids. If you need like a little picture really quick, let's see, 2 100. So here's my velocity, v of t. And I'm going to say here's 2, and I'm just going to make it real fast. 2 100, I'm going to say that's 2 100. And then 540. So I'm going to say 5, and I'm going to put a point there. I'm going to say that's 40. Remember, the velocity is in meters per minute. And then the time is in minutes. So when I find the area, just looking at dimensional analysis, meters per minute times minutes is just meters. So that's the distance traveled. Do you guys see what's going on? Or displacement in this case, right? Because I do have some negative stuff there. So look, here's my trapezoid. I'm just doing one so you guys can see. This is like base 1. This is like base 2. And you got to know a little bit of geometry, not extreme. Base 1 plus base 2 times height divided by 2. That's how you find area of a trapezoid. Are we good, guys? All right, so here we go. My first trapezoid. So these numbers here are the bases, and the difference between the x values or the time values is your height of the trapezoid. So here we go. I'm going to write, what am I going to write? 100 plus 40 times 3. The 3 comes from the difference between 5 and 2. All divided by 2. That's my first trapezoid plus. What's my second trapezoid? 40 plus a negative 120, or you can say 40 minus 120. I just got in the habit because I was with the pre-cal kids right now, and they like to write plus negatives. So that's right now is what I have. Anyways, what's the difference between 5 and 8? 3 divided by 2 plus, what's my next? Negative 120 plus negative 150. You can say negative 120 minus 150. What's the difference between 8 and 12? 4 divided by 2, close it with a bracket, make sure the 300 is on the other side. If you are scared, would I be scared? Yeah, I might be scared. I would leave it alone for full credit. We're not scared right now. We're going to try it. You guys ready? Let's try it. But if you're scared, leave it alone. Let's see. 100 plus 40, that is 140. And I'm immediately going to divide that by 2. What's 140 divided by 2? 70. And 70 times 3? Yeah, 7 times 3 is 21. So 210. Put 210 down there. Let's see. 40 minus 120. What's that? Negative 80. Negative 80 divided by 2. Negative 40 times 3. Negative 120. And let's see. What would I do on this one? Okay, I'm going to do this. 2 goes into 4 twice. So that's what I'm doing first. Negative 120 minus 150. Let's see. 150. 270. Negative 270 times 3. Times 2. 540. All right. See, I would have messed up. All right, let's see. Let's see if we can add now. 210 minus 120. 210, 110, 90? Okay, 90 minus 540. So 90 minus 500. 410. Is it 450?
Yeah.
Negative 450. Sorry, miss. You're faster than me. 300 plus 450. Negative 150. All right, there it is. So we negative 150 meters. This is fine, but let me tell you the direction that AP is going, and maybe your professor's going to want it too. What does that negative 150 meters mean? You're 150 meters to west of the origin, or to the left of the origin station. Does that make sense? I think you're probably fine. This is full credit, but they probably would like for you to say you're 150 meters west of the origin. So let me put that in here. 150 meters west of origin station. That's cute. That's cute. You guys don't think that's cute? He called it origin station. All right. No, that's fine. Please ask.
Can you explain it without the math? Explain it logically.
Okay.
Okay, I can do all the math, but I can't apply the math to the comments.
Well, all they wanted to know was, look, they're giving us a hint. Use the triple-ensemble 3 subintervals. This is how you find position, because my position at 12 is equal to the position given plus how much I do. So this right here, this integral is this right here. This means area under the curve. So I found area under that curve, but what did I use? I used trapezoidal method. See? So all I did was I found area of a trapezoid, base 1 plus base 2 times height divided by 2, and I'm going to give you this little area. And if I keep doing that for all these trapezoids and I have them all up, that's going to be my displacement. No, you can't get position from acceleration. That was average. Acceleration. It depends on what you want, right? If you want position, you need displacement. If you want your velocity at a certain moment, then you need acceleration to see how much the velocity changes. Do you know what I mean? No, don't worry. We're gonna have more. We're gonna have a lot more. We have 4 more. All right. Let's see how hard this is. You ready, Gonzaga? Can you read letter D for us? Sorry, miss. Yeah, you don't have to say it. It's given by that.
Yeah. And at time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time t equals 2.
All right, guys. I can see why this one was hard. This is a related rate problem by, let me read it again. A second train B, travels north from the origin station. At time t, the velocity of train B is given by, at time t equals 2, the train is 400 meters north. Find the rate. Okay, I got it now. I had to read it twice. So here is train A, or train B. And I don't know, train B is at a certain moment right here. What t equals, at t equals 2? At t equals 2, I'm right there. Train B. I'm going to call this B. And I'm going to call this because, okay, I don't want you guys to have bad habits, so I'm going to call this Y. As soon as you put a number on a picture, then it's static and it's no longer moving. And I don't want your professor to be like, who taught you to do this like this? Like, so remember, you always put variables. Yeah, no, no, you say Jeff High School. Okay, I'm kidding, Jeff. High School. So here's train A, and I'm going to call that distance X. Man, you guys are mean. X equals, what was X? 300. Chav, where'd you get 300 from? Right here. T equals 2. Oh, it's 300 meters east. Are we still okay? Hey, relax. Y equals 4. Okay, they're being nice. They're being nice. This is my first time doing this question, guys. So they're being real nice. If x is 300 and y is 400, what is this hypotenuse, this dashed line that I'm writing? 500. It's a 3, 4, 5 triangle. Okay. What they want, let's see what they want. Look what they want. Find the rate in meters per minute at which the distance between train A and train B is changing. Here's my picture. Train A and train B. So what they want dz dt, question mark. What's the relationship between x, y, and z that bounds all of them together? Here's my right angle. No. What relates x, y, and z? Pythagorean theorem. What's Pythagorean theorem, guys? Using Pythagorean theorem, what is this?
Y squared.
Yeah, you can say y squared first. I just like to go down the alphabet. This is why this question was hard, because look at everything a kid had to do to try to get to what they want. What's up?
If we didn't know about the 3, 4, 5, how would we find?
You would do 300 squared plus 400 squared. And remember, this is without a calculator. And then the square root of that, you would get 25,000. And then...
We would have a calculator, right?
no, not for this one. This one's no calculator. This one's a no calculator one. So this is why it was so hard, guys. This was a no calculator one. So they're being nice. Don't worry. We'll look at the rubric right now. I don't want to look at it. All right. Here we go. dx dt. Do I know what dx dt is at t equals 2? Yes, I do. Guys, this is my velocity of train A. Look, here it is. These are my time. At time 2, it's 100. Guys, come on, guys. It's velocity. It's train A. Come on.
So we're taking the derivative of Pythagorean theorem.
To relate, to find dz dt. Yes.
So the x, y, and z, those positions right now?
X, Y, and C is like like this is an x-axis, this is a y-axis. Here's my origin. So this is origin station. And then this distance x is 300 meters to the east of origin station, and this y is 400 meters north of origin station. I'm just taking this from this little thing, guys, from physics, just physics. You're going to do the same thing in physics class at the university. It's the same thing. Okay, what's up?
So the xt is velocity.
Yeah, in the x, that's right. Okay, we're still okay. If dx dt bothers you, can say VA of 2. Okay. Yeah? VA of 2 equals 100. But you're going to need dx dt, though. Okay. I'm also going to need dy dt. Can I get dy dt? Yes. That just means velocity in the y direction. VB of 2 equals negative 5 parenthesis 2 squared plus 60 times 2 plus 25. And I'm going to slow down. Guys, you guys are going to have to be able to link this. This is velocity in the y direction, so you're going to have to know that this is your dy dt.
Wait, can you explain that one more time, please?
Yes. Train B, the model for train B, the velocity of train B is this guy. So if I plug in a 2 in there, that's going to be my dy dt. That's how fast I'm moving up the y-axis here. Are we okay?
Yes.
Okay. Here we go. No calculator. 2 squared. 4 times negative 5. Negative 20. 60 times 2. Plus 25. So let's see. Negative 20 plus 120 is 100. Plus 25. And that happens to be your dy dt at t equals 2. Ooh, this one was brutal. Finally, we're going to differentiate our Pythagorean theorem with respect to what? T. What's the derivative of x squared with respect to t?
2x
Plus, what's the derivative of y squared with respect to t? Equals? Are we still okay? Okay. I'm going to cancel out all the 2's. Can I do that? I think it is easier, this is just my opinion, Everyone has their difference. Physics teachers want to isolate the DZDT. Also, some math teachers. I think it's just easier for just to plug in and solve for DZDT. So what was my x? 300. What was dxdt? Plus, what was my y? What was my dy dt? Equals z, which is over dz dt. If you're scared, maybe we're scared. What do I got to do to get rid of that 500 in front of the dz dt?
And X, Y, and Z you just got because they gave it to us?
No, x-axis, y-axis, and then I just went down the alphabet. Horizontal x, vertical y. There's my origin. They gave it to me. They gave me a name, origin station.
I know, but I like the values.
Oh, the values. I didn't know. Yeah, yes. They were given in the problem, right? All right, guys. If you're scared, you can leave it like this. dz dt equals 300 times 100 plus 400 times 125. All this divided by what?
500.
If you're scared, you can leave it like that. We're not scared. So let's try. Let's see. I don't know. Maybe I'll say I am scared. 300 times 100. What's that? 1, 2, 3, 4. 1, 2, 3, 4. 30,000. 400 times 125. 4, 5, 50,000.
5,000, 50,000.
Yes. I had to do it with coins. $1.25 times 4. So 1, 2, 3, 4, and then 5. Yeah. All right. All divided by 500. Okay, I think we can do that. What's 30,000 plus 50,000? 80,000 over 500.
How many times is 5 goes 80?
Yes, I would have deleted 2 first though. 1, 2. So 800 over 5. How many times does 5 go into 80? 5, 10, 15, 20, 20, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 16.
Yeah, no, I'm gonna leave it like that.
Yeah, you can leave it like this, guys. That would be credit.
Yeah, that's your mom's credit.
And I need units. 160 what? Per minute. Man, that was hard. I can see why a lot of kids only got 2 points on this one.
Why is it meters per minute?
Because everything else was in meters per minute. This is in meters. See right there, meters per minute. All right, here's a rubric. I have not looked at it. Obviously, I cut and pasted it, so I had to look at it, but I have not analyzed it. Did we get letter A with only 1 point? Did we get letter A? Yes. Look at letter B. They put V of A is differentiable, therefore it is continuous. Therefore, by intermediate value theorem, there is time t between 5 and 8 such that V of A of t is negative 100. I like it, but I like ours better. I don't like how they did that right there, but that's fine. We got 2 points. We got them. Letter C. Letter C is going to look the same for everyone all the time. That part. We got the position expression. We got the trapezoidal sum. Did we get negative 450? Yes. There we go. Look at letter D. 2 points for the implicit differentiation and 1 point for the answer. So you had to know Pythagorean theorem.
That's the last thing I thought would have been.
Yeah, well, guys, it comes out all the time, guys. Make sure you know like relationships. So know your geometry. Okay, do we have energy? Okay, don't worry. We'll be fine. Everyone get a calculator.
Can you take like a 2-minute break?
Oh, Cast. Hello, Cast. Cast Tech. But she just went to a break, I guess. All right.
Make sure you get your permission slip for tomorrow.
Okay. I'll try to make your luncheon, guys. I have juniors in my advisory, so I don't know if I can make it, but I'll try. All right. Here we go. You guys ready? This one is the calculator needed. It's from 2019, and the average was 2.83 points. So this one is that group right there. And I was so happy because I know for a fact, I don't remember how much, but I know for a fact that we did better than that 2.83 average by a long shot. I just can't remember what the score was. And I tried to look it up, and I no longer have access to 2019 because it only goes back 5 years. But I know for a fact that we did better than this.
Yeah, that's historic.
Not your specific exam. I just have access to the group, how many points we got of the group. All right, you guys ready? So it says, Miss Pham, do you want to read this question, please? Sorry, Miss.
Velocity of a particle p moving along the x-axis is given by the differential function velocity of p, where dt is measured in meters per hour and t is measured in hours. Selected values of velocity p are shown in the table above. Particle p is at the origin at time t equals 0.
Okay, that might be good to know. X of p at 0 equals 0. All right. Are we still okay? It says justify why there must be at least one time t between 0.3 and 2.8. So that's what I'm going to emphasize, 0.3 and 2.8, at which v prime of t, they're giving us a hint there, the acceleration of particle p equals 0 meters per hour per hour. Okay. Let's see. I'm looking at the table. Well, look at the table. 0.3 and 2.8. What theorem do you think they want me to use? No, not intermediate. The mean. What is MVT? F prime. This is. Do not write this on the day of the exam. This is just for notes. F prime of A is equal to. Actually, they use the letter C, but it doesn't matter. F prime of C is equal to F of B minus F of A over B minus A. The left one is the instantaneous rate of change. The right one is the average rate of change. You can only use the mean value theorem if you are and. So since this is velocity differentiable? Therefore, it's continuous. That's what I'm going to say. What's up, miss?
No, I know what this means last time.
No, last time we used intermediate
I know, but you said
because it wasn't a rate. It was just, you just had to prove that you're continuous, that you passed to negative 100. You know what I mean? Yeah, this is a rate, like this is a rate of change. So I'm using mean value theorem. If it just means like, okay, this is just an aside. Here's I am at A and here I am at B. This one uses intermediate value theorem because what if I tell you like, did I cross the x-axis? Okay, how are you going to prove that? With IVT?
average.
No, not average, with intermediate, because intermediate value theorem means that I cross all the values, all my values between here and here. The only way that you can cross the x-axis is if you're continuous. So this one's IVT. But if they're talking about a rate, the instantaneous rate of change, immediately you should start thinking like, oh, this must be the mean value theorem. Instantaneous rate of change equals average rate of change. Ask me, what happened? Ask me. V prime? The prime's on the velocity. Yeah. Because the derivative of velocity is acceleration. They probably put it because they want you to, it's a big hint. It's a big hint to this. Because you guys understand the mean value theorem, F prime of C equals F of B minus F of A over B minus A. So it's probably a hint for you to use, you guys, like, so they'll probably want you like, oh, V prime of P equals V of P at 2.8, see, minus V of P at 0.3 over 2.8 minus 0.3. So they probably did that on purpose to see that you could use your mean, that just kind of giving you a nudge. But before I use it, I got to state what? Make sure you state that first. V of P is continuous. All right, here we go. V of P at 2.8, what is it? Or V of 2.8. 55. V of P at 0.3. Okay. All right. Are my velocities? Okay. I'm going to start over, guys, because I feel like we're turning a little robotic. Don't make this complicated. What is the average rate of change? What is the rate of change between 0.3 and 2.8 for velocity? 0. I was 55 at 0.3. I was 55 again at 2.8. So your rate of change of velocity in that, your average, because it is between 2.3 and 2.8, the average rate of change between that time interval is 0. So because it's 0 by mean value theorem, it guarantees that I better be 0 v prime, the derivative between 0.3 and 2.8.
Because we know it's going to be 0 at some time.
Well, the acceleration, right? Okay, I'll say it again. All mean value theorem guarantees. So I have some curve. I don't know, just draw a curve like this. Well, actually, you know what? We can draw this curve here. I'm just putting some points. 0, 0. Look how I'm going to call this 0.3. 55. I'm going to say 55 is right here. And I'm going to say 1.7. 1.7. It's not drawn perfectly. I see negative 29. I'm going to say negative 29 down here. And then 2.8. I'm back at 55. And then 4. I'm not doing anything to scale, guys. So what if this graph looked like, what if it looked like that? So the average rate of change, you see 0.3 here, and you see it's supposed to be flat like that. You see this secant line? Do I have any tangent lines that are parallel to that secant line? Yes, I do. And is it by chance, well, I made it look like it's 1.7. By chance, notice that this one right here is in the interval between 0.3 and 2.8. That's all it's saying. So, and it doesn't matter. Draw any curve. It doesn't matter how you draw the curve. If I do it like this and I put a point here, and I'm going to call this A, and I put another point here and I call this B. Look at my secant line. That's 0. Between A and B, is there a tangent line that is parallel to that secant line? Yeah, way up here. That's mean value theorem. As long as you're continuous and differentiable, or differentiable and continuous, you're going to have a tangent line that is parallel to that secant line. The average rate of change equals your instantaneous rate of change at some moment. Does that make sense?
So then how exactly do we know when we use a mean or intermediate?
If you have a rate of change, you're going to use mean value. If it just wants to know it doesn't hit this value, then you use intermediate. Do I cross the x-axis? Is this value ever negative 100?
More like generalized.
You can make a connection between both. You can actually connect them. But usually, and I don't want you to see. Correct. And I don't want you to be a robot. I don't want you to be like, oh, this is obviously a rate, so I'm going to be using average rate of change equals instantaneous rate of change. It depends. You can make it a way where both will work. Okay. Does that all make sense, guys? Right. Therefore, yes. Yes. All right. I'm going to put here by mean value theorem, comma, there must, and I'm just using their language, exist a time t between 0.3 and 2.8 such that v prime of p of t equals 0. And just know your situations, right? Because, okay. Are we okay? I can see, guys, these are the hardest questions. We're doing the hardest ones. So if you're having a hard time, we are literally doing the hardest questions. All right, letter B. And look, I can see a common theme. Use a trapezoidal sum. Didn't the last one also want trapezoidal sum? Use a trapezoidal sum with 3 subintervals, and they're telling me the intervals. Let's see. 0 to 0.3, 1, 0.3 to 1.7, 2, 1.7 to 2.8, 3. So just those 3. So they're not going to use the 4 one over there. To approximate the value of this. Okay. 0 to 2.8 of v of p of t dt. I'm just finding the area under the curve. And I do have a calculator, by the way. So I'm going to go, my first base, 0. So I'm going to go 0 plus 55 times, what's the difference between 0 and 0.3 or 0.3 and 0? 0.3, all this divided by 2 plus 55 plus negative 29, close it. What's the difference between 1.7 and 0.3? 1.4 divided by 2 plus, and then this is my last one, guys, because you have 3 trapezoids. Negative 29 plus 55 times what? 1.1? Which one is it? 1.1 or 1.9? 2.8 minus 1.7? Yes, 1.72. Yeah, 1.1. 1.1 over 2. Do I have to simplify? No, but if you have a calculator, might as well. If you're running out of time, then don't even bother. I would always use the fraction feature so you guys don't mess up. I guess it's kind of hard to mess up because you're only dividing by one number anyways. 0 plus 55.
Can I put all of it off just over 2?
Yes, over 1/2 on the outside. Yeah, you can do that. Just be careful. 0 plus 55 times 0.3 divided by 2 plus, hook me up, 55 plus negative 29, no? Oh, I messed up already. That's fine. Divided by 2, all this times what? 1.4. I should have put that in parentheses, but I didn't, so that's why it looks weird. Plus, and let me put that in parentheses again. Did this start with negative 29? Negative 29 plus what? 55. Close times what? 1.1 divided by 2. Okay, tell me if you guys got this number. I forgot to put parentheses in the numerator, but it's the same. 40.75. What are my units? Guys, this is area under the curve. What's velocity? Meters per hour. And time is in, so meters per hour times hours is meters. Guys, this is, we take so much time. We don't do calculus routinely, guys. We're gonna forget some of our basics. Letter C. Yeah, maybe we're ambitious on this one. Maybe next time we'll cut it to one problem instead of two hard ones. We did, Well, we're still in good spirits, right? All right. Letter C. Here we go. A second particle Q. So now I got a second particle. Also moves along the x-axis, so the velocity between 0 and 4 is given by. First move I would do, I would type that into my calculator. Now, my preference for free response is calculator, but for multiple choice, I think you should use Desmos. But Chav, why do you want us to use the calculator? Because you're probably going to be using this over and over. So I prefer calculator for this. So here we go. I'm going to go to y equals. Oh, let me clear it because I have some stuff in there. That was from yesterday after school. Y equals, and let me type that in. What is it? Can you guys hook me up? 45 square root of x. And then I get out of there. And then cosine of 0.063 x squared. Thank you. Make sure that your calculator is in radian mode because the pre-cal kids just got done doing law of sines, law of cosines last week. So there might be in degrees. I'll make sure to reset them all before your exam. There it is on Y1. All right, here we go. Let's see what it says. Find the time interval during which the velocity of the particle Q is at least 60 meters per hour. Highlight that or underline it, because I don't think you have a highlighter that big. Find the distance traveled by particle Q during the interval when the velocity of particle Q is at least 60 meters per hour. Okay, this is a two-part question. They want us to do two things. First, they want us to find where the velocity is at least 60. So here's how you do it. Do you have a calculator? This is called the setup. You just got to set it up. Do you got to show the arithmetic for solving for t? No, not on the calculator section. On the calculator section, you're just doing this. You're going to go 45 square root of t cosine 0.063 t squared equals 60. You can probably get away with saying v of q t equals 60. I just think this is better. Are we still okay? And then you're going to tell me right here, what are those times? And okay, let's find them. Let's find them. So here we go. Go to your calculator. Go to y equals. You see how you already have this in y1? On y2, what do you think I'm going to put? I'm going to put 60. Now hold on. Before you push graph, I put 6 there. 60. Click on window. And I'm only looking between what and what? Between 0 and 4. So let's be smart. Put x min 0, x max 4. And now where it says y min, negative 10, you can leave it alone. Y max, I'm going to make it like what? 80, 90, 70, any number that's bigger than 60. And then y scale, if you don't want to see the whole y-axis like bumbled up, make it by 10 or any number that's reasonable. Push graph. Does your graph look like my graph? Yeah, the thick calculator, they're a little slower. You want to make sure to get the skinny calculators. They have faster processors. I'm not a computer scientist. It's just more modern. Okay. How do I find those values? Second trace. And which one, Miss Kyle? Intersect. You only have 2 things in there, so you can just push enter twice. 1, 2. And then you see where it says guess? Scroll to the one you want. Enter. All right, here's what I'm going to do. I'm going to look at my calculator, and I'm going to look at my booklet, and I'm going to type this number. T equals 1 point, and I'm going to put as many digits as possible. 8661815. Yep, and then store it. I'm going to use the calculator language exactly. I like to go down the what? Alphabet. So I'm going to go to my home screen. I think it's called a registered, guys. My information might be outdated, so talk to the computer science teacher, Ms. Kilgore. If I push X and I push the store button, alpha A, make sure it's the same value that you just got. Are we okay so far? All right, there it is. I stored it. I'm going to put in here in with the same language. I'm going to put an arrow equals A. You can put equals. It's the same thing. Some teachers prefer arrows. Some teachers prefer equal sign. That's fine. I'm going to get the other one. T equals. Here we go. Go back to your graph. This is why I like this better than Desmos, because you don't have the storing capabilities in Desmos because it's a watered down one. Second, calculate number 5. There's probably a hack, I'm sure. Intersect, enter, and then scroll. And then here you go. Enter. Here's my second one. Yes. Yeah, you can. But then when you do your integral, you're going to say T1 and T2. Okay, yeah, that's fine. As long as it's defined. 3 point, can you guys hook me up? Did I write it correctly? Okay. And I'm going to store this to what? B. I just go down the alphabet. Go to my home screen. X, store, alpha B. Make sure that it's the same value. Oh, yeah, it is. It is the same. Sorry. B. All right, here we go. You ready? It says, find the distance traveled by the particle Q during the interval when the velocity of the particle Q is at least 60 meters per hour. How do I find distance traveled? So tell me what I write. Integral. Perfect. Because you already defined A and B, you can use A and B anywhere now. On letter D, you can use them again, A and B. Okay, anyways, I'll stop. I'm getting too hyped. Absolute value of what? VQ of T. Make sure to put the Q in there. VQ of T. Why is it important that I put the Q this time on this one? Because I have 2 different velocities. So if you are, like, let's say you're nervous and you're like, I want to get the point for sure, then go ahead and type in the expression. But this is acceptable. This is perfect. This is full credit. Just make sure, disclosure. If you do not put the letter Q, it is possible you will not get the integral credit. Why? There's 2 different velocities. So put that in your notes. If you don't put the Q, you're not going to get the integral point. It's possible. I think if the answer matches, there's a chance that you'll get it, but it just depends. Every year, the leadership changes. So here we go, guys. Math, number 9, from A to B, alpha A to alpha B. And remember, you already have the velocity stored where? y1. Alpha trace y1. Matter of fact, I prefer you do it like this so you don't mess up with an extra, like a copy error or something. And then push enter. And there it is. Oh, what did I mess up on? I might have gotten lucky. It's the same. Why did I get lucky? It's all above the x-axis, but I would still. I'm curious to see what the rubric says. 10 point, and I'm gonna put units. Meters per hour times hours is what? And I got lucky, guys. Make sure to put the absolute value. I haven't seen this rubric. I don't know what they put in there, but we'll look at it in a little bit. Are you okay? Okay. Don't worry. We got one last one. At time t equals 0, particle Q is at position negative 90. Oh, okay. There's a particle. There's a position problem. I love it. Using the result from part B. Wait, but part B was part B was the other. Well, let me read it, I guess. Using the result from part B and the function VQ from part C, approximate the distance between particle P and Q at time t equals 2.8. Okay, read it again. I think I know what they want. At time t equals 0, particle Q is position. Using the result from part B, the function VQ. Okay, I got it. Guys, don't make this hard. Find the position of particle Q at 2.8. Find the position of particle P at 2.8. And find the difference. That's it. Find the position of both. Find the difference, the absolute value of the difference. Because they just want to know how far apart they are, right? Approximate the distance between them. Just do the bigger number minus the smaller number. If you're paranoid. Okay, here we go. Which one do we do first? Let's do the P first. Look, guys, this is why this was important. What's my initial position for P? 0. So I'm going to write, what am I going to write? I'm going to write x of P, put a P in the bottom for position of P at 2.8 equals x of 0, which is 0, plus the integral from 0 to 2.8 of v of P. And I'll slow down. You don't have to do anything because you already did this one. At least I think we did, right? On letter B, we found the displacement. What was it? 40.75. That's my position because I started at the origin. Are we okay? Okay, I'm going back to red. X of Q. So hopefully by now this is turning into automatic. X of Q at 2.8 is equal to X of 0, which was, no, not for Q, negative 90, from 0 to 2.8, and then what do I put inside here? V of Q. You probably don't have to put the parenthesis T, that just means it's with respect to T. You could have just put V of Q dt, but that's fine. Are we still okay? Take your calculator. Negative 90 plus, I don't know, whatever this is. I'm just going to rewrite it again, and I'm just going to go ahead and just write what it tells me. So let's see. That's still on Y1, right? All right, here we go. Negative 90 plus, I'm just going to, I could push 106, but I'm just going to push this right here. From, oh wait, hold on. Not from A. I almost made a mistake, guys. How come you guys didn't tell me? From 0. From 0, let me make sure. 0 to 2.8. Yeah, 0 to 2.8. 2.8. All right, yeah, I almost made a mistake there, guys. 45.93765. 45.93765. 765. What's the last? 35? Okay. How do I find the distance between both? Take this one, so I'm going to write distance between particles. What's up, miss?
Did we factor out the negative 90 from?
I put it in the front. Negative 90 plus displacement.
Yeah, why don't we have to add it to the first one?
That's a different particle. That's particle Q. Particle Q was initially at 0. Right here. Right there. Particle P is at the origin of time t equals 0. I have two different particles. Make sure that we're aware of that. The distance between two particles or between these particles, 45 point. Let's say you run out of time and you have to put the calculator away and your screen goes blank. Oh my God, Chav, I don't know what to do now. Guys, they're not going to take away your booklet. They're not going to go, don't look at question 2. They're not going to take away your booklet. You just can't look at the question anymore. So you don't have the calculator anymore. You put the calculator away. No big deal. You just go this minus 40.75 and leave it alone. Is that full credit? Yes. But if you have your calculator, it's not like you can go on to question 3, 4, 5, and 6. You still got to do question 1 and 2. If you still have the calculator, might as well just plug it in. You guys know what I'm trying to say or no? So this number minus this number. I'll just write it because I don't know where it's at. 45 point what? 40.75. 5.18765. 5.18765. I need units. If there's units, put units. Okay, we just did the 2 hardest questions in the last 10 years. Were they pretty tough? All right, let's see. Letter A. We got it. See? They took the difference of those. They got that the difference was 0. That's mean value theorem. That's this right here. We got full points. All right, letter B. Did we get, yep, we got full credit. It was just 1 point. Wow, I felt like that was a lot of work for 1 point. All right, letter C. I didn't know that, guys. I mean, I did see it, but I wasn't focused on this. Letter C, notice they put the absolute value. I didn't grade this year in 2014. What year this was? 2014. So I don't know if they would have taken your answer without the absolute value. I can call Mark and see if they did, or see if I can find some notes for this. But the absolute value for distance is always ideal. If they say distance, absolute value. And I got lucky because I didn't put absolute value and I still got the same value. Are we okay, guys? All right, letter D. It's always going to look like this. Always. I want yours to look like the rubric every time. Did it look like the rubric? Did we get 5.188 or 5.187? There it is, guys. We did it. How do you feel? Okay, don't worry. We're just going to make you do one question. Which one do you guys want? 1 or 2? Or the no calculator or the calculator? Okay, so go to the calculator one. Yeah, after this, we'll call it a day, guys.
Sean, we have 10 minutes.
No, but I think that's enough time to get through it. The mean was 4.21. Do it as a group and see if we can do A, B, C, D, at least letter D. Let's see if we can do letter A, and then we'll get one of you guys to come up and do letter A for us. Yeah, looking back, I think I would have just done this one too. Yeah, because yeah, probably not a good way to start.
I thought we said it was
Do the first lesson. Change it.
Now in hindsight that we've done it,
I have that happen too.
but I'll fix it for next year. So now when I do my APSI and I talk to you guys about that, guys just do one.
Yeah.
One of them. So the next lesson I'm gonna do for the review, I'm just gonna do one. One hard one. The thousand space, 3 digits after the decimal, truncated or round.
Okay.
Doesn't matter.
Will they lose points?
No, they can always go. Matter of fact, they don't even have to do perfect. Let's say the answer is pi. They go 3.1415, and then they just say 9s after that. They're still fine. 3.141, boom, or 3.14. Yeah, 3 digits after the decimal, rounded or truncated. They have decimals on there. It's not full blown. They don't have like the whole grid that we have with full decimals. I don't think you can store. You can't cut and paste. So there's no cut and paste. And that's what I was talking about, like guys. Because usually when we want to store something, you like store, cut, paste, and you don't have that. But I'm sure there's a way around it. I remember thinking like, what if I erase and then put B equals like this? I think there is. Yes, it's on Blue Book. On Blue Book, you open it, there's a sample test, which is just the questions from the CED. And no, it's an app. Do look at it. So we can download it right now. Is this your school laptop? Perfect. We'll download it right now and we'll look at it right now.
Okay, awesome.
Yes. Try not to use calculator language. I think you'd still be fine. But I would just write A of 3, which equals B prime of 3 equals, and then whatever the calculator tells you. You want to do that for us? Okay, Miss Kyle is gonna do letter A for us, guys. If you have questions, don't direct it to me, direct it to her.
No.
You did it right. You put this in the calculator?
Yeah.
And you got that?
Yeah.
You're good. Here, I'll show you where the calculator is at.
Velocity is acceleration, right?
Average what?
Velocity? Or no?
No.
The derivative of velocity is acceleration.
But you said the word average, though, so be careful. Velocity is the derivative of position. You want to try this one for us, Miss Kyle, please? Yeah, right now. Why not? Miss Kyle's going to do letter A for us. She's going to read the problem for us. That's right.
Nobody's paying attention.
Right.
Okay, hey guys. So I'm gonna do part A.
Well, read it for us.
Oh, okay. Find the acceleration of the particle at time t equals 3. So
What is yeah, no.
the whole thing?
Yeah.
Okay. A particle along the x-axis with velocity given b of t equals 10 sine of 0.4 t squared, whatever. For time t between 0 and 3.5, the particle is at position x equals -5 and time t equals 0.
Right.
Okay, so first I wrote this because I remember him telling us to do this. Okay, that's really
You
bad.
gotta make a connection. How do you get acceleration? The derivative of?
Velocity.
You got it, guys. I'm telling you, if you just write A of whatever equals blah, 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 I'm telling you, I've done the reading many times. You're not gonna get the answer point. Like, do that first, please.
Wait, so then I did this. And then I just plugged this into y1. And then,
Yeah, show us.
okay, how do I go there? Oh, here.
Yeah. Click it,
Okay,
and then just click.
okay. Clear. And alpha equals 1. And outside. Oh, sorry. 0.4 x squared. X squared minus
No, you already have it, so you don't have to do that. You just go A of 3 equals, you know what I mean?
and then I did math.
Like, you just take the derivative
8
of that. So you just plug it into the calculator.
x. Oh shoot.
You just go
Alpha trace y1. And then x equals, what was it?
derivative of this at 3. You know what I mean?
And then I got that.
Good job.
Thanks. Huh?
Type.
Oh, how do I go back?
No, because it just wants the acceleration
Oh, okay.
at 3. So 8 of 3 equals. Yep. Try to avoid calculator language. I saw some of you writing like B, blah, blah, blah. Yeah. Like, first of all, that dxdt that you wrote is actually velocity. If you were going to do that, the way you wrote it, you would write dB dt. You know what I mean?
Yes.
Okay. So yeah, don't. As a matter of fact, if you write dxdt equals this, that's gonna get a penalty point. That's what you're gonna get. You know. Yes, that's correct. Good job, Miss Kyle.
Wait, is there units?
Let me see. Did they put units on this? Nope. Leave it alone. If they didn't put units, leave it alone. Look at letter B. That's the one. Math 8. Right. I'm pretty sure you did. What?
Anti-derivatives we use integral, right?
All right, Rabaso is doing another read for us.
Okay, so
Read the question, Rabaso.
find the position of particle at time t equals 3. So
I want this to be automatic, guys.
since it's asking for position, I did the formula. And then I take the derivative of, or the antiderivative of velocity.
Make sure you put x of 3 here because
Oh yeah.
if you put t, there should be a t somewhere.
And then how do you do the calculator?
Scroll down with the mouse, and this right there, the right hand side. Down. Okay, show us.
And in the problem, it already says that at the position at x is 0 is -5, so I did -5 plus, and then the formula, the antiderivative.
You put derivatives
Oh,
initially.
wait. Okay.
You're good, miss, you're good.
It's
Number 9.
okay. And then 0 to 3. Y1 or
Yeah, it's a 1.
okay. And then T. So and then I got that.
Okay, I just noticed something. Have you been doing this all year? You push alpha and then the store button to get x. You can just push this button right here.
Oh.
That's x.
Oh. Okay.
All right, good job, miss.
Okay.
Yeah, I think you guys can do it. Yeah, look at it. I love this question, guys. It's just testing to see if you know the difference between one and the other. So real quick, don't worry about the answer just yet. What is that? That's displacement. What is this one? Why is it distance? Do you see the difference, guys? So all you would have to do, you don't have to do anything by hand. Type this into the calculator. Give me the values, and then tell me the difference of which one is. This one's displacement, and this is the total distance traveled. I'm assuming there are two different answers. And there it is. Cool or not cool? Oh, it's because we're getting pretty close.
How do I do absolute value?
Math and then number. Okay, let's do it. Let's do it. Let's do it together. So it's already on Y1, right? So math 9, from what to what? 0 to 3.5. So here it is. And then I'm going to go alpha trace Y1 at X. And there it is, 2.84. And then here's the other one. Math 9. Is it the same value, 0 to 3.5? How do I get the absolute value, guys? Math, and then go to the number, and then ABS. Doesn't stand for analog braking system. I thought that was funny, but you guys didn't laugh. In a vehicle, ABS stands for analog braking system. But maybe you guys don't drive. Sometimes that light turns on, and I'm like, why does it want absolute value? No, I don't. Okay, I'll stop. What's the difference between both? Which one's what? Which one's what? Yep, there it is. That's what I would write. I would say, first it wants me to evaluate 0 to 3.5 of V of t dt equals, and then give me that number, guys. I already forgot it. 8439. How many digits after the decimal? At least 3. You can put as many as your heart contents, but at least 3. Let me go to the other one. 0 to 3.5. Absolute value of V of t dt. Give me this one. Okay. Interpret the meaning of each integral in the context of the problem. Okay, well, a particle moves along the x-axis. Okay, so the displacement of particle from t equals 0 to t equals 3.5 is 2.8439, and they don't give me units, so there it is. And then here's the other one. The distance of the particle from t equals 0 to t equals 3.5. There's probably more elegant ways to say that. Maybe you should say the distance of the particle in the time interval, 0 to 3.5. Maybe it's easier, more elegant to say that, is 3.737089. There it is, full credit. All right, I know we're 2 minutes away, so let's just discuss this real quick. Just look at it. I didn't put a rubric here because I didn't have time. It says a second particle moves along the x-axis with position given by at what time are the two particles moving with the same velocity? So you find the velocity equation by taking a derivative, and then do I already have y1? Yeah. And then I find where the velocities intersect. And at those moments, I have the same velocity. Does that make sense, guys? All right. I have one question for you guys to do as homework. That's it. Just one. You're just going to get one. On average, each free response question should take how long? 15 minutes. So that's all I'm asking for you guys. I know that you got other stuff to do as well. But let's just see if we can get those gains. Did all this help today?
Yes.
Do you feel better with position, velocity, acceleration? Okay.